Hi, and welcome back. My name is Dennis, and this is Foundations Linux Systems Administration. So today's learning objectives include managing application packages in your Ubuntu VM, as well as any other Linux distribution that has the app package manager. We'll also use monitoring tools and to log investigation attempts on security-related context issues. We'll grep through health issues and other aspects that is important for logging in your administrative day-to-day duties. We'll also look at change ownership and permissions of objects. So why do things get made and read and write or executed as they do by default? We'll learn a little bit more about that as we go on. So process and application management. This is really important for anyone, regardless if you're a systems admin or you're a systems engineer. You have to understand what's going on in your system, what's running, and how do you manage those processes and applications and when to really run them. So we discussed a little bit about what files are. We got to see a sample of using the file command, and we got to see what data is and how it looks like from an operating system perspective and a cold storage perspective known as block storage. Let's get a little bit more detailed into what it means when there's a file attribute. Oops, and we'll get back to this. Getting back to this, we'll do pin right here. And the file that we look at so far is foobar.exe. Now this file has the suffix of .exe as its extension. Now just because a file, as we saw last time, has a suffix, it doesn't mean it's the exact file that it means. So if a .exe, I can name something in Ubuntu a .exe, and it does not make it a executable file from Windows only. It simply is the same file, just a different name. But by association, your operating system by default wants to see an associated suffix so it knows, hey, maybe I can interpret it as a particular file and make life a little bit easier for you. .exes are usually commonly found on Windows-based portable executor files, which are different from a Linux file. Portable execution files, or PEs for short, are only on Windows and run on 32-bit or 64-bit in modern compute today. The .exe is, again, not an indicator that it's an actual exe. It's just an indicator of what it might belong to from a standpoint of an operating system. Next, we have foobar.txt. Typically not an actual application itself, and not a self-contained one at that. What you need to use is text editors. Like we saw earlier, we have Nano, VI, and we can open and read and write text, and really any OS can do this, and it depends on what you're looking for. Windows has Notepad, Linux has Cat. You can do anything with the text file because it's just data. Similarly to just data, we have foobar.c. .c is a suffix indicator saying this is C source code, and while you can't immediately run it as an application, you need to compile it. And so if you have compilers or other editors that are knowledgeable about the C file extension and other syntax, you can compile that source code using a compiler such as GCC, MingW, and we'll see that in later lectures. But ultimately, you want to compile that source code on your target operating system that you plan to run it for on a permanent basis. So if you plan to target Windows, you want to compile it on Windows as opposed to compiling on Linux with a cross Windows compatibility. Always use the native operating system for your target audience. Next, we have foobar.tar.gzip. Again, we saw a little bit of this in the last lecture, but nevertheless, it's a gzip file that has a tar packaging. Now, you could use tar and gzip together to create the file or unpack it as necessary. Many Linux OSs have these built in by default, Windows doesn't. But you can also use a third-party utility called 7. Really, oopsie. Let's go ahead and erase that. 7-zip. All right, so 7-zip. 7-zip actually has the capability of supporting the tar and gzip format together and can run on any OS, major OS today, like Windows, Linux, and Mac. And it's a really great platform and alternative to gzip. Now, foobar.elf. Now, you might think it runs directly on Linux. You can have the suffix .elf, but remember that really anything's an executable if it really is an ELF file. So you don't have to have the suffix for bash to recognize it, but it's good to have in case you have your own custom compiles and you tend to put multiple build releases of something with other Windows file systems, so you can have that distinction on which one is which. ELF format, which means extended Linux format, means it's a binary, just like PE for Windows, but it's for Linux only. And so you'll compile applications accordingly for all that using the ELF format. Last but not least is what exactly is this foobar by itself? Well, it could be anything unless you analyze what's the actual content. Be sure to use the file command for that. And that really just showcases how important it is that you can't rely only on extension names. Always use the file command to understand what is inside the actual content first before you make your final assumption. So what's in the file exactly? Well, a file contains block data, and really it contains information about where it's located. And then there's a super block, at least with Linux. And you have the file magic. Using the file command, we have something called the file magic database. And that database is referenced about what we know about file composition, what kind of hex characters, what kind of ASCII characters, what kind of data looks like at the top and the bottom of a file to determine header and footer if it's a zip file, a regular text file, or perhaps an ELF binary file. That's all it really means. So file is actually pulling from the header information, which we call file magic information. Now remember that files can be a combination of data, data only, or app related if it's executable. Both these together can go into a package if it's related to each other for the same application. The packages that we use in Debian world is called .deb. And .deb basically says, I am a tarball for applications, dependencies, libraries, and data files, so you can actually install a package. The packages are then managed by the apt package manager. So anything with apt means .deb. Anything else outside of the Debian type of package world, like CentOS, Red Hat Enterprise Linux, uses yum by default. Now, package managers all serve the same purpose. Each one has their ups and downs, but ultimately, if you create an application package, expect to have one or more files in there, and have that package managed to be installed, upgraded, and uninstalled by the package manager inside your OS. Now, all package managers go out to what's called repos, external sites that have copies of packages already pre-compiled for you, so you can download them at will and install software most of the time for free. Package managers can also search those repos for index listings of what you're looking for in the terminal and command line. So a little bit about security management. We think we know about files, permissions, copying. We saw how we were denied without sudo rights sometimes. Let's dig a little bit deeper into the actual permissions and what it means from a Linux administration standpoint. Why AAA? Well, not the car automotive repair place, if that's what you're thinking about. AAA in terms of security stands for authentication, authorization, and accounting. To be authenticated, you say, well, is that really Dennis in the video? I need to see your driver's license. And that's driver's license. You compare my face, my name, what I've stated, and that is my credential set. Just like usernames and passwords, I only know my username and password. I shouldn't know yours. And I can authenticate that. My secret is for myself, for me to log into that system. That's authentication. Who you are that you say you are. Now, that means you can just access the system. So, authentication means the access itself. And authorization is a difference. Some students have trouble with this. So, authorization is what you can do. So, authorization basically means once you're authenticated to the system, how do you know what you can do? Are you an administrator? Are you just a normal employee? Or are you just a normal user of the application? Your authorization, based on your group membership, allows this for you. So, for instance, if I go to work, I might have authentication to go into my computer, But do I have authorization to download files from a directory that I'm not supposed to be at? Do I have authorization to go use my credentials, hence my badge, in different doors, such as the data center, when I'm not a data center technician or engineer? That's authorization. What can I do once I'm access to it? And finally, but definitely not least, and really one of the most essential parts is accounting. Accounting, you can think of from a security and Linux perspective, it has logs, right? Accountability. How can we track stuff? Well, now, stop and think to yourself. Let's go back to the previous lectures. Pause for a minute. Where are the logs located typically? I'll wait. All right. Do you have it? Well, the answer is by default, var/logs. Each of those has files accordingly. That has the accounting that you need, and you must protect those log directories and files from accidental deletion, modification, and really, the interesting thing about accounting is you also have to account for the time. So making sure your system has the correct date and time and how it's relative to your global access and users, that's critical. In addition to permissions and how we get there from an authentication, authorization, and group standpoint, we enforce the access and authorization entirely through object permissions in Linux. Really, there's three types in categories here. The object permission owner, which is usually the original creator, has complete control over the file, whether it has read, write, execute, in most cases. The owning group is the second membership of that. So let's say Dennis is not root, but Dennis is Dennis. He's the owner of one file, but he's also part of a group of admins on a team. If I'm an administrator, I can have the administrative group and say, hey, I may be able to own a file and do everything I want with it, but the administrative group, they only really need read write. They should never have to execute something. Or maybe they only need read only to inspect my work. They shouldn't have to modify my work too. Well, I have read write, but they have read. And so that's a perfect combination. Finally, we have other. Other is anyone that doesn't fit in the first two categories above. Really, anyone that's anonymous, unauthenticated, just anyone in general. Really, most of the time, you want them to have no rights whatsoever, which is a no rewrite or execute, depends on you. Now, what are some examples of how we can actually apply this? Why would I apply this? Well, we have what's called read, write, and execute. In a file that is data only, so basically no execution required, do I really need execution rights? No, not really, so that should be blank. Am I the owner, and do I expect to make additional changes after I first create it? Yes? Well, then I need write. I should be able to read that too if I'm going to write to it, in case I need to make modifications. So I also need read. So in those cases, it makes sense not to have execute on every single file if I'm the owner still. Only if the file has binary or executable capabilities should I actually need to use execution. Otherwise, don't add it unless you need it. These privileges is still considered best practice for everyone. Now there's permission octals. So read has a value of 4, write has a value of 2, and execute has a value of 1. Now, why would I want these? Well, it depends on what you're looking for. If I use the command chmod, you can certainly look it up on your own time or as in the lab. We think about our owner, group, and other. Right? Anyone else that doesn't fit in that category. My handwriting is atrocious. My apologies. But you get the idea, right? Owner, group, and other, everyone else. Well, as the owner, if I have a fully piece of application or software that I'm constantly updating, I need to execute the application, well, I want 4 plus 2 plus 1, which is 7. So I want the 7 as my first attribute. My second attribute for the group is, well, it is an executable, so maybe I want everyone to read it in that group, such as my other admin friends. I want them to execute it, and that new value is 5. For everyone else, I want 0, because you shouldn't be looking at my application. So my ultimate goal for having privacy but have allowing execution rights to my friends is 7, 5, and 0. And really, it's just another way of saying the following. If I have, let's go ahead and erase part of this. And then we'll go ahead and go back to this and say, hey, look, owner, well, I need to have read, write, execute. Cool. I need to have read and execute only. Cool. And then, of course, I need to have 0 for everyone else. When we saw these figures inside ls, that's what they mean. And so using the command chmod against a particular object like a directory or a file, you can go ahead and have those, and it makes things a little bit quicker and a little bit easier than using the multiple WR and X's across the screen. Again, totally up to you. Here's how we look at that. Octal permissions, you add them all up together based on what you need. Going back, remember that read had 4, write had 2, and execute had 1 as its decimal value. Look at the permissions first. We see that we had read, write, and execute across even pretty much everyone in the group and ownership. We had execute and read for everyone else. I want that privacy, so I'm going to say chmod 750, just like we had last time, and now we took it away for that particular folder. Now this could be a folder or a file, completely up to you. Remember that owner means that person should own everything about it. The group should really have membership permission requirements, so perhaps lesser permissions, and others with anyone else, including unauthenticated users. So please keep that in mind as you move through to security hardening and other considerations for your administration. Now let's cut to a demo and take a quick break, and then we'll follow along with that. Please go ahead and get your VMs started and spun up once you return, and follow along with me as we continue on through this course. Welcome back, everyone. I hope you had a great break. Let's get to work. Let's create a new file like foo, or even a directory. So we'll do a make directory foo inside our desktop, and we now have a directory. Let's do a quick permission check on foo. And we have, by default, it gives a lot of access, including read and execute across the objects inside and the directory itself. I really don't want that. Well, we did chmod last time, so we can also say chmod and use our octals. So we can say 750. Oops. And of course, I need to actually have our directory targeted. So now let's take a look at our foo directory again. And now we have severely limited everything. But however, we still have read and execute across everyone else. I really don't want that. And even though we did chmod 750, it's not exactly something we really want. We also, if we ever are in doubt of our octal format, we can do this. We can also use chmod with our user format. So just remember, we had 3 different groups: user, which is the owner, group, and other. So I'll put this back up here for our purposes, foo. Let's say I want to have read write only and no execution permissions on this directory. Well, I'll say user, right? That's our owner. And I want to say I have execute, but I have rewrite already. So I'm going to say -X to take that away. And I'm going to say foo. Put that up again. And now, oh no, I don't have execution permissions anymore to that folder. And what we have here is that we have now read only as a group and execute permissions back onto that other, so no permissions to the other, which is even better. So with that chmod 750 worked, so that's good. Let's do that again. And let's do that again on this folder directory. Notice that it had 0. So we'll use sudo to act as a root administrator. And I need to type my password in correctly. Now, I have this going here. So let's just use sudo for now. All right, we'll use chmod and we'll say, hey, maybe I want to add read-write access to the group again. Well, for that, I go ahead and do what I need to do, which is, interestingly enough here, we need this. So we'll do, we'll use chmod, change mode, and I'm still the owner, so I can actually change the mode whenever I want. I want to give myself execution permissions again. Great. Perfect. Now I don't have those errors anymore. I also want to say, hey, I want write permissions for the group again. So let's do G for the group, add the write permissions to foo. Let's check one last time. Perfect. Now we also have a group here, and we're not looking entirely well here. We have rewrite execute for me and the owner. We have rewrite and execute for the group, and we have no rights for anyone else. Well, let's say I want to be a little bit more open with the public. So we'll say for everyone for other, and we want them to have read rights to the foo directory. Now we have everything that we wanted. Read for everyone else, read, write, execute for the group, and read, write, execute for me. Well, that wasn't really exciting, but one thing to note, I had to do this 3 times using the human readable format as opposed to an octal. If I wanted to do octal, which makes it a little bit faster, which shows me the commands, what I want to use all this time is to use 7.5, well, maybe 7.6, 7.70 in this case, if I wanted to repeat that and do foo. And it's still the same thing. If I wanted to go 7.5.0, or even really I want 6 because I only need rewrite. No one should have execute. And really 6.4.0 makes a lot more sense because I'm not executing in anyways. And now we have our new directory right here, listing. We have rewrite for myself, read for the groups, and nothing for anyone else. Perfect. Let's go ahead and delete the directory. I just wanted to showcase what that really means. Now there's another one that we want to use, which is called ownership. So let's think about creating our file. We'll say this is echo, since the file stuff, we'll echo it into our directory called sensitive file.txt. Now I'm the owner, and then because of the text file, the shell already gave me, hey, it's not an executable, so you only need read write to it. And of course, we have read for everyone else. I kind of don't want that. So let's think about it. Pause the video for a second. What if I want permission? If I want read write for myself, read for the group, and no permissions for anyone else, I'll wait. All right. Did you get everything? Well, let's try chmod. Well, I would need rewrite, so I need 6. Means 4 plus 2, right? Read and write. I want 4 for anyone else, and I want 0 again for my sensitive file for anyone that needs to read that's outside of that group. And perfect. We have our sensitive file now with new permissions accordingly. And I'm getting way too much stuff, so I'm just going to go ahead and filter that sensitive file just to show what I want to see at this point in time. Now I'm the owner, and the group is also DW Chow. If I see what groups I'm part of, I have my own name as part of one of the groups, and that's created by default because you should have your own primary private group in case you need to share things with yourself or set yourself as a very particular group member. Otherwise, you would be a different group partition. Well, what if I wanted the owner to be root? How can I change that? Well, you might do sudo chown, change owner, sensitive file. And of course, not showing me and not letting me auto tab, which is really annoying. So ls, and then I'll just go ahead and chown sudo. That way I can act as root. And I'm going to go ahead and copy that right here and reference that accordingly. And I appear to have not used chown correctly, so I'm going to use history grep chown and see what I did last time. And call change owner. So we'll use change ownership here. We'll see what it needs. And it's saying, hey, change the owner. And here's the syntax I need to use. Oh, perfect. I wasn't changing it to the correct owner. So let's do this. We'll change the owner to, we'll keep Dennis Chow as the owner. We'll also say the group root should have read access only, because even root shouldn't have access to anything that's sensitive specifically to me. Operation not permitted, because why? Well, it's involving sudo, involving a change of ownership to someone else. So we'll use sudo ls sensitive file again. Now root is the member. So if I sudo lsla cat, or if I do sudo vim sensitive file, it should have the ability not to let me write again. And it just did, even though I set the owner to me and the group as root. Because remember, even if you shut out root, root has access to everything. So if you do cat sensitive file, oh no, I still able to edit that. If we wanted to say something else, such as lslah, oh, that's what I get for typing too fast. Let's go ahead and chown it again to be sudo only. Basically, I'm taking over this file, and Dennis Chow should only have read access at that point at best. Oh, not really, because I'm actually saying root should be the owner, and then the private root group should be the read. Let's go ahead and change that group accordingly. So the owner should be root, and Dennis Chow, DW Chow in this case, should also be only be able to read based on this permission set. All right. Now that we have DW Chow as the group member only and the root is the owner, let's see if I can actually edit that. And it says down here, read only. If I attempt to delete it and right click, saying read only, and I have no override capability because I'm no longer the owner. I am considered a group member of that file. So to actually change that back and do anything with it, really, I just want to remove it because I don't really care about it anymore. I have to be sudo again, remove sensitive file, and there we go. It's now gone, and that's how you can actually move yourself. You can't lock root out ever, but you can actually make yourself as private as needed accordingly. All right, so notice that we did groups, who am I, ID, and IDs of those group ID numbers, and we have groups. I'm sorry, groups. And those are the default groups, which is my default group listed as number 1, followed by my secondary groups as number 2. Now, something different happens when I use ID. When I use ID or groups, it doesn't necessarily show me everything I need. And I'm missing some additional groups, maybe. Well, let's do this. Let's go ahead and do groups DW Chow, and we'll see a little bit more of the information right here. Let's create a new user group. So we'll say sudo user mod will add me to a group called my test, and that we're modifying Dennis Chow. Boom. If I do groups, it's still not showing me everything I need to do. But if I need to groups my DW Chow, it's showing me my test file, and you can actually find groups inside Etsy groups. I can spell correctly, group. And at the very end, group number 1001, which I created as my test, Dennis Chow. If I do an ID DW Chow, I actually get my GID numbers, which is at the very end, which is another key point to note. Another thing is we can use different commands to use get int, which is get entry. Sorry, yeah. Oh, and then of course I didn't do get entry, which is group, which is what I'm actually filtering for. And this will actually pull from different configuration and files and giving me the same information if I didn't know anything about it. And of course I can do a grep in my test, and it pulls that one. I want to get the lines after. And of course, there's only one line after, 2 lines after my mlocate, which was installed later on. How about the lines beforehand? So groups are actually shorter in the way that you had installations and GIDs accordingly as it increments. All right, so how do we create a user though if we have groups? Again, we have to use this with sudo. So we have to add a sudo user add. We use the -m switch for creating the home directory by default. We'll say the username is test, but we don't have a password, so we have to say sudo password for test is going to be, I'm going to set a new password, and I'm going to be very insecure. It's going to say test. So if I switch user to test and say test, who am I? I am in a very different prompt, and it's quite strange. I don't have anything. I'm not part of sudo or anything like that. I'm just part of my own group. And it's got a strange prompt. And we go back to cat Etsy password, which is actually going to include my information. I'm going to grep test. It's saying that I actually have a default /bin/sh. I don't want that. To change my default shell, I want it to be bash. So for me, I need to do this. The best practice is always back up your password file or back up anything you're about to change in a major configuration. So copy Etsy password to Etsy password back. Of course, I need to use sudo for that. Now I can make the modification that I'm looking for. So I'll use vim. And then I go all the way down here. So we'll do test. And then I can change that to bash. You're right. And unfortunately, it won't let me do it, even with, because I didn't do sudo. So now I have rights. Instead of bin shell, I'll use bash instead, like DW Chow. And I should get, when I switch it over, test, test. Now I have a nice prompt, nice shell accordingly. Awesome blossom. I'm exiting out of that session. And really, that's how you can add a user. Now, if I create a user and did something with it, let's go ahead and create a new tab. I'm going to switch user to test. And I'm going to say ping. Well, I'm going to say run top. And now I'm going to say psef rep I top. And what we have here is the user test is actually running it, not me. So if you have the right enumeration credentials, you can use psef to see what that looks like as someone else is running that. So really cool information. All right, so now that we have that, we can add a user to their own sudo. And so how do you say, hey, Dennis, we want test to be an administrator. We want you to have administrator rights, but you're not supposed to be root in general. Well, I can't add myself because I can't use sudo. So who can use sudo? Not me. I'm not in the groups of sudo. And if I do sudo bash, I can't elevate myself. And it's going to say this instance report. It's going to record it in the var log file. So for me, I'm going to have to add the user test to the sudo group. So to do that, I do sudo user mod -a -g to add them to the group test. Sudo and then test as my group. Done. And now let's see if this will actually work. I'm not in the sudo's file, but you know what? Maybe I am. If I go groups, I am in sudo, but it's not changing effectively. So that means I have to exit the logout, switch user to test, test again, and then I can go sudo bash, and now I am root whenever I want. Not exactly the home hit I'm looking for, but just keep in mind that's what you need for administration. And of course, if you really want to, before we blow the user away, we're going to check out the permissions on ls/lh/home/test, and we have our users accordingly. Now, we don't need them anymore, and we shouldn't use that person, and we shouldn't especially use a weak password and guessable password such as that. So let's go ahead and clean up. Sudo user del and remove all the directories related to test. And test is currently using a process of this, so we'll go ahead and exit out of our shell connection. Let's try that one last time. Bam. And don't worry too much about this. This is using a script that'll delete as much as it can, and by default, some Linux distributions have var test created. But as you can see, we don't have tests, we just have DW Chow in the home directories now, which is awesome. And we do a cat password, which we can enumerate users for. We have nothing related to tests. So we did exactly what we were looking for. Now, speaking of auditing and security related items, we should really look up at what we've been doing just in case. We can use the history command and grep out what we need. Or even better, we can use up arrow keys. But really, if you really want to look for something in particular, Control R and you search for grep. And you can see what we had in the last runtime, what related to the grep. You can go next or back on reverse searching and forward searching if you had multiple entries that history was pulled from. Very interesting stuff. And the last thing we wanted to showcase was really about how we can get going with security. What does security look like in terms of managing our files and our sensitive areas? Well, thinking back, we had etc, which is our permissions for configuration files and everything like that. So ls, lah, etc, and we have everything here with lots of read-write only for the owner, and the owners have to be root for anything else. Everyone else, including me, as a non-sudo mode, we don't have much else right there. We can't write to it, which is probably a good thing. If I do a etc password, that's world readable, which gives me all my user information, the groups, and things like that. But do you see a password? And I don't see passwords. So we usually have a shadow file with that, and that's why you see an X. Older legacy systems had no shadow file, and so people could just grab the passwords of root users and bypass and elevate their privileges using certain tools and items for that. What we want to do is go ahead and look at cat shadow, which is actually where we have our credentials set. Cat shadow, permission denied. Well, and before I do that, let's go ahead and create a new user. Actually, I don't need to create a new user. We'll just do this. Sudo cat shadow. And you can see that I have a very interesting little credentialing here that you can actually put into a file and go ahead and crack that. Notice that every one of these do not have any credentials because these are just service credentials running that was set up by the operating system. And so really, anything that you create might be an issue here if you have a hashed credential here, which includes your type of cryptography, which is you'll have to look up on your own, your salt, and across your hashed credentialing that you can plug into some hacking tools if you ever got caught with that. Now, more importantly, I couldn't do that without kind of root, and that's because I have to be part of the group shadow directory or the root to actually rewrite or do anything with that. If I set that accidentally to 777, what do you think will happen? What do you think is possible for my unauthenticated user? Pause the video and think about it and return back. Okay, if I did a chmod 777 on it, it basically gave everyone, including the world, read, write, and execute cross shadow, and that would be a very, very bad thing. Now that's it for today's lecture. Hope to see you again soon. Thanks for watching.